All right, so today we're going to go ahead and take our binomial or GCFs a little bit further by looking at binomial GCFs. All right, and when we talk about a binomial GCF, what we're looking at is, do we have a binomial in parentheses, which means that it's bound to whatever's outside of it by multiplication, and because it's multiplication, we're going to treat it the same way as we did for regular multiplication. So if the binomials are the same, they can be pulled out. And when we go ahead and pull them out, I like to go ahead and take it and put it in the front. And you still need to go ahead and use the same set of parentheses. All right? So when we take those out, or for those of you that need to see it, when we divide this by x minus 7, okay, these are going to cancel out. All right? And what's left over is being multiplied by what we pulled out. So what's left over is our 5 minus x. All right, so when we pull out a binomial GCF, we treat it very much the same. And as say like 7x minus 21, all right, where they have a 7 in common, so 7 and 21 have a 7 in common, which means I could go ahead and divide both of these by 7, pulling it out to the front. What we then do is put a set of parentheses, and whatever's left over from the division goes in the parentheses. So these 7's cancel, leaving me with x minus 21 divided by 7 is 3. And when I distribute this, I should get back to where I started from. So this is kind of the same idea, except we're applying it to a binomial that is bound to something outside of it by multiplication. All right, let's go ahead and look at another one real quick. All right, and this is really important because this is going to be the basis of our factoring by grouping, sometimes known as the GCF method, okay? And so the factoring by grouping, one of the last few steps you have is to make sure that you have a binomial GCF, which we do here. We're going to divide out, because this is multiplication, our binomial GCF. And when we divide it out, it's going to go out to the front, just like our 7 did in the previous example. These are all going to cancel, and the second binomial is going to contain whatever was left over, which in this case is the y, the plus 3. Now what happens is when we do a full factoring by grouping, when we FOIL this, we should get back to our original problem. Okay, so this is a step of the factoring by grouping. Right, we've already been kind of looking at it. So factoring out a binomial GCF will be part of factoring by grouping, and we're going to include it while we talk about factoring by grouping. All right. So factoring by grouping is sometimes known as the GCF method because you literally are doing nothing but looking for GCFs the whole time. All right, so let's talk about the steps here. Step 1, we want to, these are also going to be 4-term polynomials. So I should mention that. These are always going to be 4-term polynomials. Okay, so our step 1 is to look for a GCF for all 4 terms. okay? And it has to be for all 4 terms. Okay, so this could be a 4-term polynomial. We want to look and see if there's a GCF that is in common for all the 4 terms involved. Okay, that could be if it's a yes, we need to take it out. If it is a no, we're going to go ahead and continue on to step 2. So step 2, we're going to split the terms in half. Okay, so we're going to create this such that we split the terms in half in front of the second sign, or plus or minus. Oops. Okay. So we're going to split the polynomial in half at this point. Okay. Our third step, we're going to find the GCF for the first 2 terms only. All right, so we're going to split it in half in front of the second plus or minus sign. We're going to go ahead and take out the GCF for the first 2 terms. Now, if the sign in front of the first term is negative, we need to pull out a negative. We'll talk more about that later. But right now we're just finding a GCF for the first 2 terms. Okay, step 4, we're going to find the GCF for the last 2 terms. Okay, and so if our split at the front contains a negative, we'll have to take out a negative again. We'll do examples where we show that a little later on with this. We're going to stick with a lot of positives for right now. Okay, so we have pulled out a GCF for the first 2 terms. We've pulled out a GCF for the second 2 terms. Our 5th step is to pull out the binomial GCF. So if we've done this properly, we should have a binomial GCF, which means we should have 2 binomials that are exactly the same. And we're going to go ahead and pull them out. And then we're going to write the leftovers. I hate to call them leftovers, but they kind of are, in a second binomial. And our last step is we're going to check by FOIL. And what we should do is we should get back to our original 4 terms. All right, we're going to do a few examples today. It's by no means going to be the exhaustive set of what we're doing. We're going to start off with some. We're going to work with them, and then we're going to work with them again as in the next lesson, so we can get a little bit better at it. All right, so let's look at a few examples. All right, so here is my 4-term polynomial, which means it's 4 terms. I must factor by grouping. And so I'm looking for a common GCF for all 4 terms. All right, there is none in this case. I have a 3, which is odd, and it goes into 6, but 3 doesn't divide into 2 or 4. All right, so right there I'm done. Okay, so I've completed step 1. I've looked for a GCF, and there is none. Okay, so I go to step 2. Step 2 says I have to go ahead and split this in half in front of the second sign. I like to go ahead and use a squiggly line so it doesn't confuse me. You can use a straight line. I encourage lines and not any kind of parentheses. And I'm going to split it in half there. Okay, so that's done. Okay, third step is I need to find a GCF for the first two terms. Okay, so my first two terms are 3x to the third minus 6x squared, and I need my GCF. All right, so these have in common, I have a 3 and a 6. So I could divide out from both of these terms a 3. And then again, my variable GCF is my lowest exponent. In this case, it's a squared. And so I can also take out an x squared. So it's the same thing as when we did division. And we're going to go ahead and the 3x squared that we're taking out is going to go in front. And whatever's left over is going to go into a set of parentheses. All right. So in this case, my 3's cancel out. I have x cubed over x squared. This is my quotient rule if you choose to use it. But I have 3 x's on the top, 2 on the bottom, which means if I cancel 1 for 1, I'm left with x on the top, so that's all that's left over. The minus sign stays. 6 divided by 3 is 2. And the x squareds are going to completely cancel. And this is what I get from going ahead and pulling out a GCF from my first two terms. My goal is to see if this reappears when I do it the second time for the next set of numbers. So that brings me to step 4. I need my GCF for the last two terms. In this case, it's 2x minus 4. All right. I need to go ahead and pull out what they have in common. Well, 2 and 4 have a common number of 2 because they're both even. And the 4 doesn't have an x, so that's all I can pull out. So I need to write my 2 in front. Whatever is left over goes in a set of parentheses. Here the 2's cancel, and I'm left with x. Minus sign stays. 4 divided by 2 is 2. All right, so let's go ahead and put it back together. The 2 keeps its plus sign that it originally had from here. And let's put it back together. So now I have 3x squared, x minus 2, plus 2, x minus 2. Now step 5 says I need to go ahead and pull out my binomial GCF. It has to match exactly. In this case, I do have a binomial GCF. And I'm going to take it out, so I'm basically dividing by x minus 2. So those are going to cancel. And my x minus 2 goes in front. And whatever's left over goes in a second set of parentheses, which is my 3x squared. And my plus 2, you have to keep the sign there. Okay, so now I've gone ahead and factored it into two binomials. I need to go ahead and check it and make sure this works. Okay, so I need to go ahead and FOIL it. So that means I need to go ahead and multiply each of these out. Now, when you multiply each of these out, they may not end up in the same exact order as what you started with, but they should all still be there. Let's go ahead and look at it. X times 3x squared is going to be 3x 1 plus 2, x to the third. X times 2 will be plus 2x. Negative 2 and 3x squared will be a minus 6x squared. And negative and a positive give me a minus. 2 times 2 is 4. Now notice that they're not in the exact same order, but my 3x to the third is there. My 2x is there. Minus 6x squared is there. and my minus 4. So sometimes your middle terms will be reversed, and that's totally okay. This checks out. Okay, so this is factoring by grouping. It's always done with 4 terms. All right, we're going to do a few more examples, and we're going to go through the steps again. I encourage you to try the next couple, and then go ahead and see if you got the same answer. Okay, so here I have all x's. All right, so I'm looking for a GCF. There is one in this case. They have a GCF of x, which means right at the beginning, step 1, I need to take an x from every single one of these and put it in front. Okay, whatever's left over will go in a set of parentheses. Basically, what this is going to do is take each of these exponents and diminish them by 1. All right, so I have x to the 4 minus 1, which is x to the 3rd, plus, all these are pluses, so I don't have to worry about signs. X to the 3 minus 1 is x squared, plus x to the 2 minus 1 is x to the 1st. If you want to write a 1, you totally can do that. And x to the 1 minus 1 is 0. I need to still have 4 terms. So anything to the 0 power is 1, so therefore there's a 1 here. The reason for this is we need to still have 4 terms, because if I were to go ahead and distribute this out, I need to get back to where I started from. Okay, so I need this 4th term to get this 4th term. All right, so now I've pulled out my GCF. Okay, I'm trying to take the arrows out. And now I need to go to step 2. Now step 2, because I pulled out a GCF, this x here I don't worry about. So right now I'm going to kind of forget about him, and I'm going to only focus on what's in parentheses. Which means I need to go ahead, split it in half in front of the second sign, and go ahead and pull out my GCF from my first 2 terms. Okay, they have in common the lowest exponent, which is x squared. So I need to divide out an x squared, and that x squared is going to go in front. So I have an x squared, and what's left over is x. Now x squared over x squared is 1, so I have an x plus 1. Step 3 sees I need to take a GCF from the last 2 terms, and if I look at these, I go, well, x and 1 don't have anything in common. They always have something in common. Remember that any x has a coefficient of 1. So if you don't see anything, they have a 1 in front. And it's very important that we still go ahead and take that out. So these need to be divided by 1. Okay? So when I take a 1 out, I do need to write it. And write the leftovers in a set of parentheses, which is x plus 1. Okay? So my final equation that I'm working with right now, I have an x squared, x plus 1. We're ignoring the original x from section 1 here. We'll get back to him. And this is all pluses, so plus 1, x plus 1. Okay, we need to go ahead and pull out our binomial GCF, so divide by x plus 1. Those are all going to cancel. My x plus 1 goes out front. The leftovers go in a second set of parentheses, so x squared plus 1. And at the very end here, my x that I pulled out as my GCF needs to go out front. Okay? Sorry, that was step 4. All right. So now what I need to do is I need to check. And this is how you're going to check it. You're going to start with your FOIL first. So I'm going to ignore the X on the outside in red, and I'm going to FOIL what's in my double parentheses. And our goal is to, from the foiling part here, get back to here, and then when we add our red X, get back to here. Okay, so let's see what happens here. So I have, right now, X plus 1, X squared plus 1. And I'm going to go ahead and FOIL this. So first, X times X squared is X to the third. X times 1 is X. 1 and X squared is plus X squared, or 1 times X squared. And 1 times 1 is 1. Okay, notice they're still not in order. That's okay. All this needs to be multiplied by the red X that was on the outside, which is now black. And I need to distribute this through to each piece to hopefully get back to where I started from. Okay, so X to the first and X to the third is X to the fourth. X to the first is X squared. X to the first and X squared is X to the third. And X times 1 is just X. Now what I'm looking for is, do I have my 4, 3, 2, and 1 that I started off with? Let's check. I have 4, 3, 2, and X to the first. This checks out. All right, so I've totally gotten back to where I started with. This had a GCF in it. All right. And don't worry if it's the first time you've seen this. We'll do a few more of these before we're done with this section. Last one here is this one. I would love for you to try this on your own first and pause it and try it. All right, so I'm looking for a GCF for all 4 terms. This fails because 7 is not divisible by 5. So 1 is done. There's no GCF for all 4 terms. I go to step 2, and I need to go ahead and split this in front of that sign. And I need to look at the first 2 terms. So I have 5y to the third minus 25y squared. I need to look for the GCF. So they're both 5 and 25 are divisible by 5. And my lowest exponent is 2, so there's a y squared in common. My 5y squared will come out to the front, and what's left in parentheses, my 5's cancel. I have 1y left. My y's cancel here. 25 divided by 5 is 5, and there's a minus, so I have y minus 5. Step 3 means I need to take my second group, and I'm going to include the sign here because we need it. Whenever you have a minus at the split, you're probably going to have to pull out a negative, which means your signs are going to change. All right? So I have negative 7 plus 35. Now, I need a y minus 5 when I do this, and right now I have this plus hanging out here. I need to pull out a negative to change my sign to make it match here. And so I need to pull out a negative, and both of these are divisible by 7. And I have no other y's, so I just have the one y. So the negatives on the first one are going to cancel, and 7's are going to cancel, leaving me with just y. So we divided by negative 7. We're left with a y. And now we're dividing by negative 7 on this one also. A positive and a negative give me a minus. This is going to change my sign. And 35 divided by 7 is 5. Right. Now notice now these two match, which is what we really want to happen here. Let's put it all back together for step 4. So step 4 means I need to go ahead and take and pull out my binomial GCF. All Right. And if you're in doubt of your signs, you can distribute this here and double check. Okay? Says I need to go ahead and pull out my binomial GCF, which means I'm dividing these by y minus 5. My y minus 5 will be written up front. And whatever's left over that I didn't cross out will go in a second set of parentheses, which will be my 5y squared minus 7. Right. Now I should be checking this. Right, so that means I need to FOIL to check. And I encourage you to go ahead and FOIL on your own, but I'll get 5y to the third minus 7y minus 25y squared plus 35. And if I've done this right, all of these should match what's in black on the top. Notice again, my middle two terms are kind of reversed. It doesn't matter as long as they're there. So this is a really quick and brief introduction of the different types of factoring you're going to come across with factoring by grouping. Go ahead and work on the practice problems, and we will discuss this more in the next lesson.